Hey guys, this is Siri, and in this video we're going to be talking about deep learning using PyTorch. We're actually going to hold off on the PyTorch part for our next video, and today we're going to just be talking about, what AI is, what machine learning is, and, what deep learning is, why it's so amazing, why it's different than previous methods. What makes deep learning such a hot topic and why it's so useful for this current day and age, and what it is, just to sort of demystify that sort of complicated thing we all think it is. Okay, so AI, it's a broad range of disciplines, and it's been researched quite extensively these days. And the reason is because we have a lot more data at hand, and we can do more things with it, right? Like previously we didn't have that much data to work with. And now that we have so much data and we have a place to store that data, we can make good predictions with it, and we can make a good analysis with it so that we can improve our daily lives and solve many, many problems with it. But the thing is, this notion of AI and this thought of this idea of AI seems to, for some reason, invoke a thought of a thought that machines might be able to take over someday, and that they're gaining some sort of human intelligence that hasn't been there before, and they might use that in a cruel way and destroy the human race and all these sorts of crazy things. And although machines have been able to these days complete tasks that only humans used to do, and it's a big change, right? But an important point to note is that machines, they don't learn they don't learn from the rules that humans come up with. They don't learn, they do learn, but they don't learn the same exact way that humans do, with this self-consciousness and self-awareness. But the idea is the same, but there's no real human intelligence that's being gained here. They actually learn through examples. And so, for example, a task like generating text, right? We only used to think that humans could do that because humans have that sort of sophistication and this sort of human magic that just makes us able to do these things. But in fact, you don't actually need that, because machines now with deep learning, they can generate text. And so what we've done instead of, giving our self-consciousness to a machine, what we've done instead is that we've come up with different algorithms that can, approximate some pretty complicated, pretty non-linear math. And we'll talk about the differences between linear and non-linear and these functions when we get to neural networks and how the actual architecture and structure is like. But these algorithms, they can help us automate tasks that we've only thought humans could do in the past. And these algorithms actually fall under a subset of deep learning. Okay, and in deep learning, we train this mathematical web, which we call deep learning. We call it deep neural network. And so if this mathematical web is filled with these complex functions that can help us go from an input, and then we apply some sorts of computations, and our input goes through the computations, and it goes through this big box you can think of, and like you get an output. It's just like regular math function. Like you have f of x is equal to like x plus 2 or whatever. You pass in an x and then it does some computations and then you get an output. Except this deep neural network has so many more complicated and just like pretty complex functions, and so we can make better and more accurate predictions. Or we can do like other sorts of things that aren't just predictions. We can do some like different kinds of analysis, which we'll be talking about in future videos. Okay, so using the data that they are fed, which can be thought of like examples to learn from. That's what I mean by learning from examples. Like we pass in past data, which are the examples to learn from. And based on that, the deep neural network can approximate complex functions, like I've said, and have many series of inputs and outputs in order to learn from the data and make conclusions. Okay. An interesting question to ask is why deep learning is so amazing and why it's unlike anything we've ever seen before. So previously, in the past and even today, right, like machine learning depended on something called feature engineering, okay? And so features are just, these patterns that you can extract from your data. And, like for an image, it could be like the edges. It could be like the different, like where the objects are in the image and like these little patterns like that. And feature extraction is like when you get those patterns out and like you really grab them and analyze them. And in order to do that, we need to, apply some transformations on the data, right? So, and this is all based on numbers, right? I'm talking about a mathematical web. So, like, we're going to be talking about, how we convert our data, which might not be in the form of numbers, to numbers and and express them in a way that our model can understand. Okay. And so feature engineering is, like handcrafting these certain transformations that you need to apply in order to get the information that you want. And so, like I said, like locating edges and other things could be a form of this feature engineering. But imagine if you had, like 10,000 or 100,000 times more data than you do right now. Like handcrafting those features that we've been talking about would be an extremely gruesome task, and it would also prove to be quite inefficient. And so deep learning, like we've started talking about why deep learning is so amazing, and this is the reason why, is like deep learning allows the machine to learn these patterns by itself. Okay, so you start off with a blank slate, you don't know what the heck is going on, and then deep learning allows you to learn, or it allows the machine to learn these patterns by itself. Okay, just based on examples without any human guidance. The guidance that we were talking about before was, saying, hey, machine, this is how you locate the edges, this is how you, locate the center and see these different objects in the picture. Or like it could be with paragraphs and sentences, so like natural language processing. So instead of having to spoon feed the machine with like these different rules and these different feature engineering, these different forms of feature engineering, instead of having to do that and spoon feed the model of that, you're just saying, hey, do it by yourself. Learn the most precise patterns that you can to apply this to a new image when you see, like one that you may see in the future. Learn it well now. Learn it the best that you can right now so that you can use it in the future. So that's what deep learning is all about. Okay? It's guided by its own mistakes through a process called optimization. And so, like at the beginning, the whole training process. And we'll go in more depth about this, but like the training process is a process through which the model, the machine learning model, really learns the data. And so it's not going to be perfect at the beginning, right? That's what like machine learning is all about. That's what the learning part is all about, right? You make a lot of mistakes at the beginning, and you don't make as many mistakes as you did at the beginning at the end. So that's that process, and you get better, right? So you optimize these different parts of the computations, which we'll call parameters, and we'll go in more depth, like I said, in future videos. Okay, so from this like mathematical web of inputs and outputs that we were talking about, our network, our neural network, learns these patterns autonomously. Okay, and in deep learning, there are 3 important things that we need to implement. 3 main ideas, right? The 3 basic components. And so we have one, which is like a way to crunch our data. Okay, and we're being pretty informal about this right now. Okay, so just a way to crunch our data, a way to, like crunch your data, and really process it, pre-process it, and feed it through the model, and apply some computations to it so that we can get the output that we want. So we need a way to crunch our data. Number 2, we need to define our model and like initialize, like a base version of our model before the numbers start to get really messy, and before you lose track and you lose like your understanding of what's actually going on with the numbers. I mean, you'll obviously know what is going on, but the nitty-gritty stuff about like which parameters are getting multiplied by what, and like you're not going to know everything about it. So we need to initialize a base version of our model before things start getting messy with all the numbers. Okay, and number 3 is the training, autonomous training. Okay, that's where the model learns. That's where, like if you feed it another image, you'll get an accurate result. Okay. And the whole point of this training is to get more accurate results than you did before, right? And so there needs to be a way for the model to understand how far it is from the actual output, right? So you have an input that you pass into your model, and the model might not be as accurate as you would like, okay? At some point, not at the end probably, but like maybe like somewhere towards the end. And it needs a way of knowing how far it is off, how far its prediction is off from the true output, and we call this the ground truth. And so we need a way to measure this discrepancy and this difference between the true value and the predicted value. And we use something called a loss function to measure this. You get one singular output, okay, and it measures the difference in a nice way. And the reason why we need to know how far it's off is because the model needs to learn, right? First, for example, if you have like a math test, or you have some sort of test that you're taking at school, and at the beginning, like the first time you take a test, or like a quiz or whatever, you get some things wrong, and or maybe it's practice, maybe it's not a quiz, but like you're practicing and then you get a few things wrong, and then you learn what things you got wrong, And the reason you do that is because the next time you do it, the next time you do like a practice worksheet or like a quiz or a test or something, you don't make the same mistakes and you learn from it, right? This is the optimization that's going on. So you need to know how far you're off at the beginning so that you can do better next time. So that's what the whole loss function is all about. And this is a mathematical function, once again. This is all math, this whole thing, right? Because the model can't learn qualitatively. I mean, you can encode, I'm using a fancy word here, you can encode these qualitative things, these qualitative descriptions into something called a tensor, which is a way you can store that qualitative information in the form of numbers. Because numbers, you need your data in the form of numbers in order to actually pass it in to your model. So that's why it all needs to be like numbers and like floating point decimals and whatnot. You can't pass in just a regular image. You can't just pass in a paragraph. You need numbers. And so we'll talk about tensors and we'll talk about the way to store this information in another video. Okay? And also just to reiterate, like a loss function, you want your loss to be smaller every time, right? Like if you learn from your practice worksheet, you want to have fewer mistakes next time, right? So we want to see our loss getting smaller every time, okay? Every time we iterate through our data, and we'll talk about the entire training process in another video, okay? Don't worry about it now. We just want to see our loss getting smaller every time we iterate through our data, okay? And it's like you have a set of problems, and like you go through it once in one iteration, and then you go through it another time, and then another time, and another time, to reduce the number of mistakes you get. So it's something like that, okay? Okay, so I think we talked about what deep learning is, right? Let's insert the cell above. Okay, so intro to deep learning. We talked about the 3 fundamental things that we need to do in our training, in our neural network. And also, we talked about feature engineering. And we talked about like why deep learning is so much better and makes better predictions. Okay, and we talked about a loss function, and we also talked about some optimization. So the loss function happens first. Well, we're training, and then we see how far we're off, and then we optimize based on that. And we want to see our loss getting smaller. Okay, so this was an intro to deep learning. We didn't get into the PyTorch stuff yet, and that's intentional. We'll go through that in another video. We'll talk about what PyTorch is, why that's so amazing, why we use it for deep learning, and why it's such a great choice. And we'll talk about how PyTorch even does this. Yeah, we'll get into the details next time. Okay, but I hope you learned something new today. Yeah, and don't forget to stay curious. Thank you so much.